Okay, yeah, so let's start. So, hello everybody, this is Luboš Peklo from CFD Support. Welcome to the webinar on Turbomachinery CFD, which is a CFD simulation workflow for all standard rotating machinery. The test case for today will be Francis turbine. Just in case of any technical problems, feel free to contact us in the future and we will gladly answer your questions or reminders. So the webinar is going to take about 1 hour. In the first part, I will show you how to simulate Francis turbine in Turbomachinery CFD. In the second part, there will be a Q&A session dedicated to your questions and my answers. Feel free to put your questions. You can put them just below to the comments, or there is a special Q&A window. You can put your questions there, and I will answer them later in the webinar. Just feel free to put questions because it's your time. I am here for you. I will gladly answer all your questions, and I will stay with you until the last question is answered, and it's your time. This webinar will be uploaded to the YouTube channel, to the CFD Support YouTube channel. It's easily accessible through our website. So yeah, no problem. Okay, so I guess I will share you my screen now. So I'm going to share my screen, so you will see what I see. So it's the right. Yeah, I click here. I'm sharing you my screen. So I believe you can see my screen now. So, okay, so I guess you can see my screen. Yeah, so I'm now in Turbomachinery CFD. So here is the Turbomachinery CFD graphical interface. This is basically how Turbomachinery CFD looks like. Before I come here, let me start with a brief description. What is Turbomachinery CFD? I'll go to my web browser, which is, I'm sorry, it's here. Okay, it's here. Okay, I'll go to my web browser with, in the blank page, I say, Turbomachinery CFD. I let Google search for it, and the very first item is Turbomachinery CFD from CFD Support. I click on it. So this is our website. So here you can find many important information. So Turbomachinery CFD is unique software. It's based on OpenFOAM, and it was especially designed for CFD simulations for all standard rotating machinery, such as pumps, fans, compressors, turbines, water turbines, Kaplan Francis, both axial and radial machines, both compressible and incompressible flows. Maybe let me put just a quick review of its unique value proposal. So I will go briefly. So number one is Turbomachinery CFD has no licensing policy, which means our clients can keep Turbomachinery CFD forever and they can use it for unlimited number of users, jobs, or cores. So yeah, and that gives the investment in Turbomachinery CFD a permanent value. Number two is Turbomachinery CFD is fully automated, which means all the workflow from the start to the final results report can be run by a single command or by a single click. Number three is Turbomachinery CFD is open source, so that makes it easily customizable, and it can be easily modified to your own purposes. So it can be easily modified due to the open source nature. And number four is the real tutorials are included. So the user has no doubt about the best practice settings. So there are real machines that are already preset. So you can basically take one of them and replace the geometry, change the settings, and run it. So it's really ready, it's prepared. Yeah, so there are many other benefits of using Turbomachinery CFD. I'm not going to go for all of them. Feel free to contact me. I will gladly answer or describe everything in detail. So feel free to contact me anytime, and I'm here for you, and it's a pleasure to say what it is. So yeah, so that's the Turbomachinery CFD. I'll go very to the top in its page. I will click the workflow example. Here you can get more technical details. What are the inputs? What are the outputs? What's the operation system? How to run some examples, and I will start from here. So perhaps the most important information from today's webinar is all the information is available on our website. So I have pasted some major links below to the comments in this webinar. So below in this webinar, below this window, you can see the major links. You can click. You can get even more information in detail. Anyway, Turbomachinery CFD is available both for Linux and for Windows. Turbomachinery CFD is transparent, so the trial version is available for 1 month period for anybody, for everybody. So anybody can try Turbomachinery CFD, and afterwards he or she can decide to buy it or not. So basically, you have all the information before you take any decision. So on our website, on CFD support, you can click download. You can click download software, and here you can see there is Turbomachinery CFD demo for Windows or demo for Linux. So for example, you can click Windows, and you just put your email here. You can download the trial version, and yeah, you can ask us for a license file for 1 month, and we send it to you, and you can start working immediately. Also, it's important, there is a step-by-step PDF which you can click, and there's all the particular information. So in Windows, you basically do download, you install Turbomachinery CFD together with OpenFlow Windows, and then you download the tutorial, and you can just couple of clicks in the graphical interface, and you see everything, how it works. You see the final results. So it's really easy to make it work. Okay. Yeah. So Turbomachinery CFD is fully served from graphical interface, the GUI. The graphical interface of Turbomachinery CFD is ParaView. So the preprocessor is also the post-processor, ParaView. You can also work from terminal, but most of people prefer working from graphical interface, but the decision is up to you. Today's webinar is in Windows, so this is Windows. The Linux workflow is the same, exactly the same. So it doesn't matter which operation system you use, the workflow is the same, the graphical interface is exactly the same, and also the terminal if you wish. Okay, so let's start working now. So today we will work on Francis Turbine. This tutorial is available. You can download it, you can test it. It's available on our website. Again, on our website, you can click download. Then you can click download cases. And here in the cases, you just go for the Francis water turbine. And again, you can download the test case here. It's 20 megabytes, not too big. You put your email, download it, and you have it. It's everything included, right? I'll get to it later in this webinar. So it's the Francis turbine. Yeah. All the tutorials can be downloaded, or a couple of tutorials. It's 1, 2, 3, 4, 5, 6, 7 tutorials are in our download cases section on our website. You can put them into Turbomachinery CFD, and you can simulate them, change settings, simulate them, and really you can get extensive reports and extensive knowledge already right now, right this afternoon. Okay, so the aim of water turbine designer is hunting for the head, I mean the turbine head, the flow rate, of course, the torques, and yeah, and of course the turbine efficiency, right? So that's what are the outputs. Each Turbomachinery CFD simulation case has its data inputs. That's what you can download on our website. Those are the surface model all the time. So you put to Turbomachinery CFD, the input is the surface model, which is the 3D geometry of your machine. In this case, it's Francis turbine, and the surface, then the configuration file, right? So you have the surface model, 3D geometry, like from CAD or from your from any software or from your input, and then configuration file. Configuration file is simple plain text with all the case settings inside. So maybe I can show you. Yeah, this is how the tutorial looks like. It's the surface model, individual surfaces like the inlet, outlet, blades, shroud, hub, walls, draft tube, spiral, and there is a special file which is Turbomachinery CFD configuration file with the settings inside. I will open it in text editor in the Notepad++, which I can recommend. It's great software. Okay, so and this is the configuration file. You say here my machine type is water turbine. I want to run on 6 processors, 60 iterations, each point, revolutions, and yeah, and all these important settings. So it's plain text file, but this is not very important because you can set everything in ParaView, right? So 100% of workflow is here in ParaView. So you can open this file in ParaView. So you can just double click, and it opens in your ParaView after you install Turbomachinery CFD, of course, and in the settings, it's the .tcfd file. The extension is .tcfd, and in the settings you can see everything. All those things is here in the bar on your left hand side, right? So you say which file the settings is written down, but you can set it here. So type of machines, etc., etc. I'm not going to go for all the details right now, so I will keep the details for the discussion later. But the settings is on your left hand side, and what you do next? So you fill the settings, watch your surface model, and once you're satisfied with your settings and surface model, you click the TCFD manager, which is special filter, a special library for ParaView. It's in your, of course, it's in filters, but there's a small icon with colored arrows at the top in your bar, in the menu. So you can click it, and you will get the TCFD manager, which is a filter where you can run the simulation. So here you can say, I want to write this case down, and you can say, I want to run everything automatically, which means creating the mesh, creating the case setup, running the simulation, and finally, after the simulation is finished, the results report is written down, and you can update it anytime during the simulation. So, which brings me, that's the input, the surface model of your machine, your rotating machine, for example, this Francis turbine. The input can consist of any number of components. So, for example, this model has 3 components: the spiral, the impeller, and the draft tube. And yeah, so everything is done automatically. So according to your settings in your configuration file, how it usually works with Turbomachinery CFD and in OpenFOAM and in any CFD available, you never start from the scratch. You always start from some tutorial or from some working case from the past, and you just replace the geometry and modify the settings which differs, and then run the simulation. So that's usually people work in CFD, and that's the most effective way, and that brings that's the fastest way how to get results. So yeah, the surface model. So once you do the settings, you run everything. You can get back all the time. You can update the report anytime, and this brings me to the results report. So I have opened now the results report, which is that's really important part of Turbomachinery CFD. So any CFD simulation, any simulation you do has its report. So anything you simulate has its report. Yeah. So this Francis turbine has this is the report. So I'm looking to the simulation report. So this simulation is finished because it takes some time. So I have it simulated here right now. So I'm not doing everything. I'm not running it now. It's simulated already from this afternoon. And okay, so this Francis turbine has 3 points, 600 rounds per minute. It's the rotation speed, mesh sizes, yeah, 6 processors, and you can see the results report has all the results you perhaps are interested in. So, for example, what's the flow rate, how it develops in time, what are the residuals, what is the efficiency compared to the flow rate, or how the efficiency developed in time, what's the torque, how it developed in time, and how it's compared to each flow rate point. What's the total pressure difference, which is the head, basically. What are the total pressures per interfaces? So every component has its inlet and outlet, so we call them interfaces. So how you're basically the meaning is how the total pressure is spent when the flow is flowing through your machine, and again in time and against the flow rate. What are the magnitude or the velocity magnitude per interface? What are the angles? What are the average angles? For example, what's the circumferential angle, and what's the meridional angle at every interface in average? So that it's important. It's circumferential. Both of them are like circumferentially averaged. So again, how was the average angle? That's very important for the rotating machine designers. Okay, so this yeah, I wanted to be like really quick at the beginning. So that was the general overview. So important is there's a graphical interface. 100% of the workflow is in this interface. Yeah, maybe I should say just a little bit about the visual post-processing, because the numerical post-processing, the integral values like the efficiency, torques, flow rates, total pressures, it's the report. To visualize the flow, you can use our special filters. It's a set of filters. We call them turbo blade post. It's part of the Turbomachinery CFD. and there you can use a number of them. The 4 views are the most important. That's the meridional average. So you can, any results you have, you can use a special filter which is called meridional average, and it shows you your results. Any field can be averaged in the to the meridional plane. It's again important for rotating machine designers, and also blade-to-blade view, which is a special view where you can visualize any span at any level between hub and shroud. So you can decide to go for 50% or 20% of height between hub and shroud, and then you can visualize, for example, relative velocity or pressure, and you can guess how smooth is your flow over the impeller, for example, or any blade cascade. So yeah, so this was just the general introduction. I wanted to be really quick, really brief, just give you the impulses, and the message is the workflow is comprehensive. It has everything what is available in the market, and it's really smooth, it's really fast, it's automated, and it seems to be really great tool for CFD Turbomachinery. And okay, so maybe it's time to go to the webinar. So I'll stop sharing my window. Okay, I'm still here, and I will take a look if there's some question. Right. So, the questions here. Okay. So I can't see the question in the Q&A window. So that's one thing. Okay. The other thing is I will take a look into my web browser, which is it's here, and take a look to the webinar window. And here we go. Okay, there's no question here, so I'll go to my email. It's here, and okay, so no questions yet. So I'll go. Okay, so I'm here for you. So feel free to put your questions. Just don't hesitate about it. It's really, yeah. So put any questions, even if I'm asked any time to put a question, I think I always say, oh, it's stupid. I don't say that. Just say that. Say that no question is stupid. Just come on. Yeah. Come on with questions, and I will continue with a case description, right? Maybe you are interested, what's the configuration file, for example. So I'll share my desktop now again. So here we go. Yeah, that is the desktop. And this is what I see now. And I'll go to perhaps the case. The case, which is, oh, come on, okay, it's here. Okay, here's the case. Maybe I should show you. Maybe it's too slow, so I will stay here. So here's the case. So first of all, the surface geometry, right? So it's perhaps the easiest way. So the surface geometry is the 3D geometry, but just the surfaces, right? So it's not the volume. Those are the surfaces, and it's very useful to have it decomposed into the regions. So, for example, in my case of this Francis turbine, I have the white spiral, the red impeller, and the green draft tube, right? And these are surfaces in .stl format. It's like stereolithography format, which is typical for all CAD CAD software and tools. So it's really common to deliver the surface geometry in this format. And what is important, every component, I have 3 components here, and every component has to be waterproof. That's a must, it's the condition. So it has to be waterproof. And ideally, it should be vertex to vertex, which means maybe I can show you, yeah, that's the best way. I can show you what's vertex to vertex. So I'm opening the spiral, for example. There's a spiral .stl, there's a spiral dip, and also there is also the inflow, and perhaps so I will open these. I will say okay, and this is gonna show me the surface. The surface is okay, so it's here. Well, I need to click the centering. Why it's not? Oh, come on. Well, something is going to. Okay, I don't know why. Perhaps something wrong in my mouse. Is it the mouse? It can't rotate, so it doesn't matter. Okay. Well, it was okay. No. So it's not going to rotate. Do I? At the last attempt, no. Okay. So it's something wrong in my settings here, just around. So I wanted to show you what's the vertex to vertex meaning. It's not very important. That means the vertexes. That means the vertexes are of the surface are meeting each other. That those are exactly the same points. But I realized it's not very important, so I'll go ahead. So okay, it stopped rotating. Okay, it doesn't matter. Well, yeah. So that's the Francis case surface geometry. I guess this is obvious. The very next important thing is there's the configuration file, right? You give all the details here in the bar, which is called settings of the water turbine.tcfd. Of course, you can choose any name. Okay, so I'll go. Maybe I should go one by one to explain a little bit. Well, yeah, what's really important information is the configuration file options. Is you can see it in the products in Turbomachinery CFD. You can click the Turbomachinery CFD workflow example, and there in the Turbomachinery CFD input, there is the Turbomachinery CFD configuration file manual PDF. So you can open it, and here you can see what are the options, right? So for example, machine type can be a pump, fan, compressor, turbine, or water turbine, and etc. etc. So here's a manual, and here are every parameters and their values which are available. So again, all the information is on our website. So you do not need to get everything in this webinar. I'm here to answer your questions basically, but everything is available. Also this manual online. So here you can come for the options, for the parameters and for their values. I'll go back to the settings, and I will briefly just comment those settings. So machine type is water turbine. Coordinate system is basically the axis of rotation of your machine, its point and its directional vector. Geometry parameters, yeah, you can scale maybe you can have your, for example, your surface model in millimeters. So you always, in an open form, you always need to scale to meters. So yeah, so my model is in meters, so I do not need to scale. Feature edges is not important. Gravity vector can be imposed. You can go compressible or not. So it's water, so it's incompressible. So I'm not clicking the checkbox compressible, right? So dynamic viscosity, density, reference pressure, temperature. You can use the cavitation risk, which is a special feature which evaluates a critical pressure and shows you in which cells there's a risk of cavitation. This is important. Here you say number of speed lines. So you may have different number of rotation speeds. So you can say number of speed lines. So you can have like 3 speed lines. You define the speed for each of them. You may have speed line points. So each speed line may have any number of points. So for example, we have 3 points here, but you can have 1 speed line and 3 points, but you can have 10 speed lines and 5 points each, or any number. Each speed line can have any number of points. So it's really custom. Yeah, this is important. The boundary conditions, right, are in the configuration. So water machines are usually run with the volumetric flow rate. So we prescribe the volumetric flow rate, and we watch for the torque and the pressure difference, the total pressure difference, which allows us to evaluate the head, the machine head. So you say here what's the volumetric flow rate, what's the turbulent intensity, what's the turbulent dissipation at the inlet, and at the outlet we fix the static pressure. So we usually say there's atmosphere here or something like that. Simulation settings, number of processors, some limits on your critical fields, the numerical order. Of course, the numerical scheme of first or second order, averaging window. It's you always get the instantaneous values and also the averaged values. So this averaging window number says how many last iterations are kept in the memory and averaged over last n iterations, and in this case it's 100. Yeah. You can use convergence check, which means if, for example, if the efficiency does not change more than 0.1% over the averaging window time, the simulation can stop and can go to the next point. And by the way, any point which is being simulated can be skipped. Is written down, and you can go to another point. So it's really like interactive. You can interactively check your results, change the numbers, and really like take the action in your running simulation. Okay, the initial conditions are it's obvious. So those are initial values in the cell centers. Here are the components. So we have 3 components. Each component has its inlet, outlet, perhaps some wall. Also, rotating component has hub, patch, and blades. Some simple component has just the inlet, outlet, and the wall. You say what's its surface geometry corresponding to it, and there are some mesh settings. I'm not going to go for all the details. You can find the descriptions in the manual. What's important? Important is, I will describe just one parameter here. It's extremely important. This is really critical. The background mesh size specifies in meters the size of the basic cell of the background mesh. So it's the meshing tool is automated. It's a SnappyX mesh, and you always have some background basic mesh, and it's going to be refined and refined and refined with respect to the boundaries. And this background mesh size defines how fine is your mesh. And it's extremely important because it defines the size of your mesh in the end, and it defines the time of your simulations finally. So it's really important. Background mesh size, a really important parameter. Of course, you can prescribe anything. It's really comprehensive. So all the parameters you can prescribe in OpenFOAM, you can prescribe here in Turbomachinery CFD. But it's automated. There's the best settings, best practice settings included. So you can take control, and it's you who decides which level of skills you put in. So either you are not like CFD maniac. You can use the automated settings, or you can be CFD really expert, going one parameter to another parameter, and you can really put all those parameters in detail, test anything. Everything is open, and it's extremely effective because it's automated, right? So in TCFD Manager, which is the filter for which allow you to take control over your simulation, you can watch the results, you can skip to the next point, you can update the report anytime. It's important. So anytime during the simulation, you have your report and you see how the results are developing. So you can skip anytime, you can click anytime, you can abort the simulation anytime, and you always take control over your simulation. And it's really, because it's automated, it's really easy to change the settings, run again, change the settings, run again, take a look, and really it's extremely effective. By the way, in our company, we were so surprised how much effective it's really effective in a big way. It's automated, and you just change one parameter, click run all, and everything's going to run again. So it's really effective. Okay, maybe it's time to go back and take a look. Okay, so I will go back. Okay, it's me again. I'm going back and I'll take a look. So the questions, I can't see any questions in the Q&A window. Then I will take a look in the webinar page. There's no questions. There are no questions, and my email, I will check. Great presentation is possible. Okay, so I can see Burak Rainier is asking me. Hi, Burak. What's the time in Los Angeles? It's -11. Oh my God, so much in the morning. Okay, thanks for your question. Is it possible to run Turbo CFD on multiple hosts in parallel to achieve high performance? Of course it is. Yeah, of course it is. Currently, it works that way. Currently, you can run Turbomachinery CFD from the terminal on multiple machines. It's exactly the same. You run just one command, and it works that way from the terminal. In the next Turbomachinery CFD version, which will be like in September, it's coming. There will be special parameters in the graphical interface. So from September, also in the graphical interface, you can specify like IP addresses of the hosts, and you can send you can tell the Turbomachinery CFD, and it does it for you. So it will be automated multiple hosts. Yeah, thanks Burak for your question. Yeah, okay, and good luck to Uber Cloud. Uber Cloud, yeah, it's a perfect service. Yeah. Okay. Well, it's here. Okay, I'll go back to the Q&A. Not here. Nothing here. In the webinar, give me a second. Okay, nothing here. So I think this is it. So anyway, if you missed giving me a question today, doesn't matter, just feel free to contact me anytime. The CFD support is transparent. The project we do is transparent. So it's we are here for you. We are waiting for you. We believe we create great software for turbomachinery and also great open form things, and we believe we have something great. It's something which is really great, and it's time for us to tell the world. It's a big challenge for us to tell the world out loud and show people, and that's it. Yeah. Actually, I can see finally I can see the question, so I'm going to answer the question. Is there a way to implement a user-defined function by using your platform? From C. Joseph Yoon. Thanks, C. Joseph Yoon. Thanks for this question. User-defined function. Yeah. So we are speaking here about the open source project, right? So the project is open source. So on the side of CFD, there's open form, and you can do anything because the source code is open, right? So user functions are out of the question, right? Because you have the source, so you can implement anything. So user-defined functions are for black boxes, right? For commercial codes. That's the interface to allow the users to make their some changes, some little functions for them. Yeah, but I think this question is a little bit off topic because we are speaking here about the open source project, right? Turbomachinery CFD, I mean the CFD processor, which is the C++ project, which allows the automation, is not open source. It's our internal project, and we give it with Turbomachinery CFD. That would be different, but the CFD itself, it's the open form and it's open source. So yeah, the user-defined function is out of question basically because it's the source code is open. Okay. Yeah. Okay, so I think this is it. I guess this is it. So thank you for your time. Thank you for watching us. We'll be in touch. So good morning to LA, to Burak in here. Good luck with your project, by the way. And this is it. Thank you for your time. And yeah, let's stay in touch and feel free to contact us anytime. We will transparently answer all your questions. Yeah. So thank you for your time and yeah, bye.